All right, chapter 4 here, we're going to have simultaneous equations. So, right, equations, we have been solving equations for a bit here, and then maybe some earlier portions in our chapter 1, 2, and 3, we might have dealt with a little bit of simultaneous equations. Not sure whether you guys remember that in the earlier tutorials, we had some problem sums that involve the use of simultaneous equations, right? So chapter 4 here is more to formalize and to revisit certain techniques of simultaneous equations so that maybe if you had problems dealing with the questions earlier in the earlier chapters tutorial, after chapter 4, you might want to go back to visit that. Yeah. Okay, so for all equations, right, when we solve, if there is more than one unknown variable, then we need to look at the equation, the number of equations to see whether we could solve the variables or not. Okay, so the example of 7x plus y equals to 9 here, x is a variable, y is also a variable, which means to say that with a single equation, we won't be able to solve for both of them. In other words, if you have your x to be a certain value, then your y would take on the respective value. Let me give you an example. Right. So given in our textbook, it tells us that if, right, if, or you can say when my x is equals to 1, then we'll know that 7 times 1 plus y would be equals to 9. You see, y is going to be dependent on the value of x itself. So if my x is 1, right, then we have 7 times 1 plus y is equals to 9. If you subtract both sides by 7, you end up with y being the value of 2, right, which is this example that you're seeing here. And let me change the color. So at the same time, let's say if our x is equals to 2, right, then 7 times 2 plus y will be equals to 9. And you can see that 7 times 2 is 14, right? So if 7 times 2 is 14, then if you subtract both sides by 14, you'll end up with the y value of negative 5. Now, you can see that dependent on the value of x, y would be affected accordingly. This is the issue with a single equation where it contains more than one variable, right? One unknown variable. Okay, so if x and y are only linked by one relationship, or rather one equation, then there's no way for us to tell whether or not there's just one set of answer, right? It here provides you with two sets of answers, and both can be correct, right? Both of them can be an instant, right? So there are in fact infinite instances where x can be something and then y would be a responding value in that sense, right? There's a reason why you might have heard of the definition where x is considered an independent variable and then y is a dependent variable. Okay, so whatever x is, y will respond accordingly. Okay, so the thing is, if you have the same number of equations as per the number of unknown variables, I'm talking about this here. So instead of just having 7x plus y equals to 9, we have another equation of minus 3x plus 2y equals to 1. So if they are given simultaneously, right, simultaneously just means at the same time. At the same time, right? If both equations are given at the same time, then we'll have the ability, right, to solve both of them such that there is only one set of solution that satisfies both equations, right? And this is the basis of solving for simultaneous equation, and this is the most basic. So we are not limited by two equations and two variables. It's possible for us to have three unknown variables and three equations. I'm just not, but I'm saying that this is not the case for our syllabus here, right? But the basis is that simultaneous equations are not limited to only two equations and two variables. We can have more than that, right? So you can have x, y, and z, and then you have three different equations, and then you can also solve them simultaneously. It's just that you have to maybe do more steps as compared to two unknowns and two equations. So for this case here, right, the two equations provided there, you can see that there is only one set of solution that satisfies both of them. So when x is equals to 1, y is equals to 2, right? Just now we have already proven in the earlier working here. We can already tell that x is equals to 1 and y equals to 2. This is one set of solution. But if you provide another equation, then I can also, in a way, test whether this set of equation works, right? So let's say x is equals to 1, y is equals to 2. If I put it inside the second equation here, right? If I put it inside the second equation here, if my x is 1, okay, I'm just write it down here. Using the second set of equation, right? If you put x to be 1, then y to be 2, okay? If you work out the number here, it is -3 plus 4, and that should give you the value 1. So both left and the right-hand side are the same. Okay, it means to say that when my x is 1, y is 2, it satisfies the second equation also. And this is the only set of values that satisfies both equations. All right? And this is, in a way, a unique solution. Okay? So to solve for simultaneous equations, right, there are three main methods to solve them. The first method is known as the elimination method. The second one is substitution. And the third one is the graphical method. Graphical method is very similar to what we have done earlier in chapter 2, right? Was it chapter 2? I think so. Okay. I might be wrong about remembering which chapter it is. But in any case, we have done graphical method earlier in the earlier chapter. So later you'll see that they are pretty much the same thing. So let's start with the elimination method. Okay, as mentioned, elimination method is basically to remove one of the unknowns, right? By tallying the same coefficient of the unknown. Okay, it's easier to understand once you use an example. So we first look at the example given, right? We have two equations here, and they are respectively labeled as equation 1 and equation 2. So the first equation, right, with the dot and a bracket 1 tells us that that's the first equation. So the first equation is 3x plus 2y equals to 60, right? That's my first equation. The second equation is x minus y equals to 90. Yeah? So given these two, right, the elimination method is to choose to eliminate one of the variable, right? There is no hard and fast rule on which one you must eliminate. You can choose to take away x. You can also choose to take away y, whichever is easier for you. Okay, so there are many ways to do elimination. Elimination, you can do addition, you can also do subtraction. Either way, it works. Okay, the idea is just to remove one of the variables as long as you can do so. So, okay, so I'm going to show you the first one. Now, in this case here, assume we choose to eliminate x, right? We want to remove x, and the first thing that you want to do is to match the coefficient. Okay, coefficient in order to do addition or subtraction. Okay, sorry for that. Right, so the first thing I want to do would be to multiply the equation by 3. Okay, so I'll take equation 2 and then I'll multiply it by 3. Okay, I'll take this guy and then I'll multiply by 3. And when you do that, the resultant is that everything is multiplied by 3. Okay, so you can see that x minus y is equal to 90. If you multiply both sides of the equation by 3, you end up with 3x minus 3y equals to 270. Yeah, and we'll call it equation 2a. Right, so equation 2 and equation 2a are the same thing. It's just a different look. It's just the same as saying half is the same as 2 over 4. Yeah, let me put that in. So equation 1 and equation 2 are the same. It's the same as saying that half is equal to 2 over 4, right? It's just that the look of it is different, but the value or the equation didn't change at all. Okay, half is still the same as 2 over 4 if we multiply both the numerator and the denominator by 2. So the elimination method requires this as long as we match, right? We match the coefficient of what we want to eliminate. Okay, so let me highlight this. If we choose to eliminate x, then your first task is to match the coefficient of x. Okay, and that's the reason why I multiply equation by 3. Right? I multiply the equation by 3, and that allows me to match the coefficient of x. So now you can see that equation 1 and equation 2a, they both have 3x. Yeah, both of them have 3x. And then you have the option to eliminate them now, right? You can either do 1 minus 2a, or you can also do 2a minus 1. It doesn't matter, right? You can do a simple subtraction, right? You either take equation 1 and subtract equation 2, 2a in a sense, or you can take equation 2a and subtract equation 1. The sequence does not matter because we know that 3x minus 3x would always be 0. Okay, subtracting them away would eliminate the 3x. So you can see that the choice taken here would be 1 minus 2a. So we are going to take equation 1. You can see that equation 1 here has 3x plus 2y, and that's why you have 3x plus 2y. And then we'll subtract, okay? We'll subtract equation 2a. And equation 2a is the 3x minus 3y, okay? Which is this portion here. Right? We literally do a left-hand side subtraction and then do a right-hand side subtraction. So you observe the elimination, right? It is the left-hand side of both equations subtracting each other and the right-hand side of both equations subtracting each other. The sequence must be the same though. So if we put equation 1 minus 2a, it must be subtracted in this sequence. So you take equation 1's left-hand side minus equation 2a's left-hand side. After which, on the right-hand side, you do the same thing. Okay, on the right-hand side, you do the same thing by taking right-hand side of equation 1, subtract right-hand side of equation 2. Right, we don't change the sequence in which you do. If you change the sequence, then the answer will be wrong. Okay, because you get a different different value in the subtraction. So be very mindful of that. How you subtract must be followed up in the same sequence. Okay, so what we did is to take equation 1, subtract equation 2a, both for the left and the right hand side, and then we'll proceed to simplify the entire thing. So let me just write one more step in between. Okay, be very mindful of careless mistakes. I still have students committing them from time to time. So if you subtract, right, note that the inside is a minus, so the minus minus becomes a plus. Yeah, so this is plus 3y. Right, and then 60 minus 270 will be negative 210. Right, therefore, you can see that the 3x would cancel out with the 3x. So this and this is being deleted, whereas the 2y plus 3y will give us the 5y. Okay, it's a plus 3y, so be very mindful when you, be very careful when you open up the brackets. Okay, and in this case, once I arrive at this step, you will notice that I've successfully eliminated my x, and the only thing that's left behind is 5y equals to 210, right? Negative 210. So you just have to divide the entire equation by 5, right? You have your answer of your y. Okay, so that gives us y equals to negative 42. And last but not least, you can then put this value inside either of the equation. Okay, this procedure of substituting our y equals to negative 42, okay, you can put it inside any equation, right? It doesn't matter. Okay, either of the equation will satisfy the answer. Okay, so you can put it into equation 2, you can put it into equation 1, you can put it into equation 2a. It doesn't matter. They're all the same. Okay, so the choice taken here will be substituting it back into equation 2, right? Equation 2 is x minus y equals to 90. Yeah, equation 2 is x minus y equals to 90, which is why you'll see the substitution of the y being negative 42. Okay, so you then simplify the entire thing. Your answer for x will be 48, right? And that will be our elimination method. Now, at the bottom of the page, right, there is this checking where you verify your answer. This step here is optional. Okay, it's a good habit, but it's not a step that contributes to your marks. Okay, but I would say you might want to do this, but you might want to do this last. You know, when you're done with the entire paper, then you do the checking. Okay, don't do this for every single question unless you're very sure that you have the time. Okay, but I do recommend that you do it once you're finished with the paper. Okay, so the checking is simple. All you gotta do is to substitute the solved values, right? We have solved our x to be 48, our y to be negative 42. We put it back inside the equation, right? And then you verify that the left and the right hand side are the same. Okay, so the last statement you see at the bottom of the page is that elimination doesn't have to be for x. You can also eliminate y, right? You can also eliminate y by corresponding the coefficient, right? So if you look at the original equation, 3x plus 2y equals to 60, and then x minus y is equals to 90. The alternative is that you can also change the let me copy down the 3x plus 2y is equals to 60, x minus y is equals to 90, right? Yeah. Okay, so just now we eliminated the x, right? So when we eliminate the x, we matched the coefficient of equation 2. But alternatively, I can also take this guy and multiply it by 2. Okay, if I multiply it by 2, this is what I'll get. So between equation 1 and equation 2a, right, you'll see that they have a matching coefficient, okay? 2 and 2. You'll notice that one is a plus 2, the other is a minus 2, okay? The thing is, if one is their opposing signage, right? One is a plus 2y, the other is a minus 2y. To do elimination, you can add the equations together, right? So if you take equation 1 plus equation 2a, okay, you choose the plus, they will cancel out each other. So the left-hand side of equation 1 will be 3x plus 2y, and then you add them together, the left-hand side of equation 2. Okay, that will give you this, and you'll be a case of 60 plus 180. Right, so you'll see that when you expand them, okay, like this will be minus 2y. So you see that the 2y and the 2y will remove each other. Okay, so you can also do this method and you can solve it to the same answer. Right? Okay, that will be our elimination method. So I'm going to solve example 1 here, 2 examples using the elimination method. So the first equation there, 3x plus y is equals to 11. Now, to do elimination for this particular question, it might be easier to eliminate y. Okay, you're not fixed. It doesn't have to be eliminate y. It's just that sometimes when you look at it, it's easier to do one of the other. Okay, in this case here, if I multiply equation 1, right? If I multiply equation 1 by 7, I can immediately do an elimination. But if I choose to eliminate x, right? Okay, if I choose to remove this version, it's a little bit more troublesome because 3 and 5, it's a little different. You can adjust the numbers a little bit, right, by either multiply equation 1 by 5 and then equation 2 by 3, okay, you can do that such that they both become 15x, right, before you remove them, okay? So personally, I find that this takes up a little bit more time and it's not as efficient. So in that case, it will be easier for me to multiply equation by by 7, right? Equation 1 by 7, then this will be a 21x plus 7y is 77, okay? And I'll call this equation 1a. So now between equation 1a, I can take equation 1a, subtract equation 2, right? So when I take equation 1a subtract by 2, so the left hand side of equation 1a would be this guy, and I minus the left hand side of equation 2, 5x plus 7y. Then the right hand side, I maintain the same sequence, 77 would then subtract 45. Okay, so if you work out the entire thing, this will be 21x plus 7y subtract 5x minus 7y, right? And I'll be left with 32. So the 7y and the 7y will cancel out. So definitely I'll be left with 16x, which is 32. So my x has to be 2, right? If I divide both sides by 16. Then last but not least, since I already solved for my x, all I gotta do is to substitute it inside one of the equation. So substitute x to be 2 in the, let's choose equation 1. Yeah, so I'm gonna put in equation 1, then it'll be 3 times 2 plus y is 11. So I know that 3 times 2 is 6, subtract both sides by 6, my y has to be 5. Right? So my x is 2, y is 5. Done. Right, question B here. So question B here, it's in a fractional format, definitely for this case here. There are a few ways you can approach this. You can either make them all into a integer kind of coefficient, or you can leave them as fractions and work on the fraction itself, right? But for me, it looks like by multiplying equation 1, right? If I take equation 1 and multiply it by 3, I would already have the coefficient that I'm looking for. Alternatively, I can also do multiply equation 1 by 2, right? Okay, so for this case, when I multiply it by 3, I will end up with x plus 3y over 4 is equals to 9, right? And this is equation 1a. Then I can also choose to do, I'm gonna write sideways, the other option, the alternative. Okay, the alternative is I can take equation 1 and I multiply it by 2, right? They result in different things, but because they cancel different things also. Okay, you end up with a y over 2 equals to 6. Can you see the reason? Now the multiply by 3 version, okay, when I multiply by 3, what happens is that I can take this equation and I eliminate x, right? The rate version, this one allows me to eliminate x because now I have both equations x and x, right? Both equations will be x and x. But for the alternative version, okay, when I multiply by 2, you'll notice that the y would be the same. Okay, both cases will be y over 2. So when you do elimination, we will be eliminating y. Okay, so this is to eliminate y. Whereas for the first version is to eliminate x. right? Either way, you should get the same answer. It really doesn't matter. So I'm just going to do the x version. Okay, wait, x, right? So I'm just going to do the x version, and I will take 1a and subtract equation 2, right? This will be x plus 3y over 4. Essentially, 3y over 4 is the same as 3/4 y, right? Then the left-hand side of equation 2 would be x plus y over 2. Then maintain the same sequence, it will be 9 minus 4. So when you expand, okay, I'm going to write it as 3/4 y, it'll be easier to see, minus x minus half y. Okay, this will give us 5. The x and the x will delete each other. 3/4 minus half, right? 3/4 y minus 1/2 of y would give me a remainder of 1/4 y. Okay, and this would be my final answer. Multiply both sides by 4, and I will have my y equals to 20. Right, last but not least, you still have to solve for your your x. So substitute my y equals to 20. I am going to put in equation 2, right? Equation 2 will be easier because x plus 20 over 2 is equals to 4. And 20 over 2 is 10, right? Which means to say if you subtract both sides by 10, okay, you can solve for x. So my x is negative 6. Okay, the alternative. Right, for practice, you might want to attempt the alternative to eliminate the y, okay, on your own. Right. So the second method is the substitution method. The substitution method here is it's another way to solve the simultaneous equation. As the substitution method says, right, basically we are trying to replace one of the variables in the other equation. So the relationship here is that I'm going to manipulate and make one of the variables the subject, and I'll substitute it inside the other equation. Okay, remember it must be substituted into the other equation, otherwise it doesn't make sense to have one equation and work on itself. Okay, so if you put one of the variables from equation 1, you put it into equation 2. If you use equation 2, you put it in equation 1, right? Vice versa. You have to always put it into the other equation. So for this case here, the question is 3x plus 2y equals to 60. Oh, it's actually the same question as earlier. Okay, it's the same question as our elimination method. Okay, it's 3x plus 2y equals to 60, and x minus y equals to 90. So for this version, right, we would want to substitute one of the variables inside the other equation. So we choose equation 2 because equation 2 is in a neater way. I have x minus y equals to 90. And when I add both sides by y, right, I can change the look of it, right? So if you add y on both sides, you end up with x equals to 90 plus y. So by making x the subject for equation 2, it is now x equals to 90 plus y, right? And we are going to put this guy, okay, we're going to put this guy inside equation 1. Right, if you notice, this here is where x is going to be. Okay, so the equation 1, right? Equation 1 was 3x plus 2y equals to 60. So instead of 3x now, we are going to replace the x with 90 plus y. So it is 3 times of 90 plus y, then plus 2y equals to 60. So you notice that using this method, x is in a way also eliminated, right? Through substitution, we can also eliminate the variable of x. And now everything inside is going to be of the variable y. Right? So what we do is after we do the substitution, we expand the entire bracket. 3 times 90 is 270. 3 times y is 3y. Okay, so going from here to here, if you expand, it'll be 270 plus 3y plus 2y is 60. Yeah. So sum the 3y and the 2y together, that'll give you 5y. Subtract both sides by 270 and then divide both sides by 5. Okay, you end up with the same answer anyway. And then you do the same for your x by substituting the value of y back inside the original equation 2. Right, let's take a look at the example here. To do elimination, to do substitution, here I have equation 1 and 2. Okay, so for ease of working, it seems that if I were to choose equation 1 to substitute my y, I might have an easier time. No, there's no fixed choice here. You don't have to use equation 1's y. You can do equation 1's x. You can also do equation 2's x. And you can also do equation 2's y. Up to you. It doesn't matter. Right? Eventually, you're going to get the same answer. Right? It's just that for this case here, by letting equation 1, okay, to be the case, I subtract both sides by 2x, I get a substitution expression that's much faster. So I'll call this 1a, right? So if I subtract both sides by 2x, I will then have 1a. Okay? And then I'm going to put 1a, so substitute 1a inside equation 2. Okay, you must always remember you must substitute inside the other. It must never be the same equation. Okay, so I'll put 1a inside equation 2, and this will be 5x plus 3. Instead of y, it is now 4 minus 2x. Then this will be equal to 7. Okay, I'm going to simplify the entire thing. Expand the brackets. 12, 6x, 7. 5x minus x minus 6x will be negative x, right? And the other side would be 7. Okay, let me just... Okay, so if you subtract both sides by 7, you end up, and then you add both sides by 5, so you end up with a 5 minus x is 0, so your x must be 5. Okay, so now I have this. I am going to make use of this because it's much faster to just say, since my x is 5, my y is already re-expressed there, right? So I'll just use it directly. And it will be a 4 minus 10, and that is negative 6. Okay, I'm going to do the same. So it seems that the second question here is similar in that sense, right? By repurposing the whole thing there, if you subtract both sides by 2/3 of x, right, you'll end up with y equals to 4 minus 2/3 x. Okay, I'm going to call this equation 1a. So what happens now is I am going to substitute equation 1a in equation 2, right? So I'll end up with 8x plus 2/3 of 4 minus 2/3 of x equals to 5. Okay, just now I didn't really do a highlight, but now maybe I'll just put it in so everyone, you could see this is what I'm trying to do. Right, so yellow, the yellow highlighted basically all the substitutions. So now I'm going to simplify the entire thing. 8x plus 2/3 times 4 is going to be 8 over 3, right? Minus 2/3 times 2/3 is going to be 4 over 9x. And this is 5. Right, so since they are all fractions, you might want to kind of make them into integers. You can do that, or you can just work on it directly. Up to you. It doesn't matter, right? So I'm going to do it directly. I'll do 8x minus 4 over 9x. So 8 minus 4 over 9, you end up with 7, 5 over 9, right? 8 minus 4 over 9, you end up with 7, 5 over 9. So 7, 5 over 9, right? I'm going to put it in improper fraction. Okay, you can just press your calculator. 7, 5 over 9, you should end up with 68. Okay, 68 over 9x. Okay, and at the same time, I'll be left with 8 over 3, 5. So subtract both sides by 8 over 3, I'll end up with 68 over 9x. 5 minus 8 over 3, which means to say 2/3, right? I'll end up with a 7 over 3. Okay, last but not least, to solve for x, all you got to do is to multiply both sides by 9 over 68. So I'll end up with 21 over 68. Right, you're not done yet, so you still have to solve for your y. Since your y is already given equation 1a, so I'm going to substitute it inside equation 1a. So therefore y is going to be 4 minus 2/3 multiplied by 21 over 68. Right, simplify the whole thing. I'm going to need my calculator for that. Okay, 21 over 68, and y will be 129 over 34. Right, moving on. Oh, there's the answer at the bottom. No, any case. So last but not least, I'm going to do the graphical method. Right, the graphical method here is similar to what we have already done so far, right, in the earlier chapter. So it's the same as what we have done. So There's nothing new that we're going to teach here. In essence, having the two equations, all you got to do is to sketch them out. I've already explained, right, in the earlier chapter that when you have two different equations, the intersection between the two lines or curves, whatever, the x-coordinate will give you the answer, right, for the equations. Okay, so for example, what you see here is y equals to 2x plus 60, and that's your first equation. And then you have another equation of y equals to x plus 90, right? That's your second equation. All you gotta do is to put it in the same graph and see where do they intersect, right? There should only be one intersection because it's just one x value, right? There should only be one x value that works, right? Okay, let's see. So for the equation here, 2x plus 60 would be this guy. Okay, so this line is y equals to 2x plus 60. The other line would be y equals to x plus 90. Yeah, x plus 90. Right, so you draw these two equations and then you will see that there is one intersection, and this one intersection, if you draw your graph accurately, right, you will then be able to plot it down to the answer of, oh, my line is kind of slanted, huh? It's supposed to be 30. Let me try to redraw it again. Yeah, it looks straighter. So the intersection reads off as x to be 30, and that's your answer. Now, technically speaking, you can also read horizontally to get the answer for y. Yeah, it's supposed to be 120, so you can see that horizontally, it should also give you the same intersection. So in essence, this coordinate is 30 and 120. So this is the x coordinates answer, and this is the y coordinates answer, right? If you're accurate enough, you can actually read it directly like that. Okay, you see? So the answer is x equals to 30 and y equals to 120. All right, so I can't really do this very accurately by hand, so it is also not very reasonable for me to just plot it out for you. I would say I will do the plotting for you, right? And then I'll show you what accurate drawing is. So I will have to do the plotting here, but it will be good for you to pause the video, right? And then give this a try, right? Using either your own accurate sketching, or you can try to use a graph paper. Right, in any case, let me just plot it out. So if you draw them correctly, right, okay, I hope you know how to draw straight lines. It's basically just to plot 2 points, right? So let me give you an example. Maybe for this guy here, 4x plus y, right? You will say you can re-express it as y equals to negative 4x, right? So what you want to do is to choose any point, right? Any 2 points will do. So when x is equal to 0, you can solve this to be y equals to 0. This means that the line passes through the origin. Then you can also put another value, maybe when your x is equals to 4, right? And then you can also substitute it in. My y will be negative 16. So what you want to do, okay, graphically, is to plot 2 points, which is the origin 0, 0, and the other point would be 4 and minus 16. Okay, so when you plot them, you then be able to get okay, I can draw 0 and 4 minus 16. Okay, you may not see anything at this moment, but I'm gonna plot it for you. Right, then at the same time, let's do the other one. Okay, so this guy here, the second equation would be y equals to x minus 1. Right? If you add x onto both sides of the equation, you'll be able to see that. Okay, so you add x to both sides. The left hand side will be y, the right hand side will be x minus 1. So what we want to do is to draw y equals to x minus 1. And once again, just choose any two values. X is 0, your y would then be negative 1. And then you choose a second value, say maybe similarly you also want to do a 4, y would then be 3. Okay, so you have two coordinates that you're going to draw. The first coordinate in this case will be 0 and minus 1, right? So you have to draw 0 and minus 1, and then here you'll draw 4 and 3. So the two dots, you'll join them together. Okay, let me draw it out. 0 and minus 1, 4 and 3. Right. Okay, just hang in a moment. I am going to show you the plot. Okay. All right. I think I might have to zoom out a little first. Where should I put this? Here. Okay, I'm gonna put it outside. Or maybe I can shift everything in. Okay, here's what I'm gonna do. I'm gonna shift this whole lot up. And I'm gonna shift this whole lot down. Okay, and I'll shift the graph in. Okay, there we go. Right, so here's the plot, right? And you can see that the first, the red and blue, I've kind of colored it for you also. So you can see the red line is y equals to negative 4x, right? Y equals to negative 4x. And the blue line is y equals to x minus 1. And I've also plotted the two dots, or rather the two coordinates that we are supposed to use to plot the graph. So it's not limited to these two coordinates. You can use any value that you substitute. It's just that I use x to be 0 and 4, right? You can use x to be minus 2 and positive 2. Doesn't matter. As long as you have two dots on the line, you can join the two lines, sorry, the two dots, and you will get a straight line, right? And then you can see that they intersect at exactly 1 point. Do you notice? Right, both lines intersect at one particular point. And if you're accurate enough, you can read it off the graph paper, right? So I can't exactly freehand this thing and then show you that it is accurate to 0.2. You should be using a graph paper for that. That's why I show you this plot. Okay, so if you want to practice this, go and try on the graph paper, and then you can see that with the intersection, they'll be close enough, and then you read off the x coordinate, you will be able to get the answer of 0.2. Okay, and likewise, you can also read off the graph. Okay, the intersection point will give you a y coordinate of negative 0.8, which is why we have the answer of this. Right? Okay, so I'll leave the second question B for you, right? Go and practice on that. And I'll finish up with the application questions. Okay, so just two questions here. Example 4. So example 4 here says there are two types of weights, right? 4 grams and 8 grams, right? The weight itself. Maybe I can do a little bit of a diagram. So this is a weight. A weight looks like that. Okay. And then the 8-gram weight, which is slightly larger. So you have two weights here. One is a 4-gram weight, the other is an 8-gram weight. Altogether, there are 27 such weights. Okay, so we don't know, but we know that it's a mixture, right? There are 27 of them, and the total weight add together. So the question here is we don't know how many 4-gram, we don't know how many 8 grams, but I know that there's a mixture of them. Yeah, there's a mixture of them, and they add up to be a weight of 156 grams. Right? This much we know. So let's call the M to be 4-gram and N to be 8-gram weights. We are supposed to form a pair of simultaneous equations. Right? So the thinking here is there are two such informations. One thing that is fixed is that the weight is fixed to be 4 and 8. Right? We also know that there are 27 of them, and the total weight together is 156 grams. So the 27 weights is the first information. The second information would be the total weight. So you can make use of these two information separately to formulate a pair of simultaneous equations. Right. So for question A, I know that if I take, so M here is the number of 4-gram weights, right? That means if I take the number of 4-gram weights multiplied by 4 gram, which is 4 times M, if I add, wait, actually I don't need this first step. So I'm going to take the number of 4 grams plus the number of 8 grams weight. I know there are 27 of them. Right? That's the first information. Agree? So if there are, for example, if there are 10 4 grams, for example, if there are 10 4-gram weights and then there are 17 8-gram weights, the total would have 27 of them. Okay, M is the number of the weights. Okay, M is the number of 4-gram weights, N is the number of 8-gram weights. So M plus N should be the total number of weights. Okay, number of items, think about it. So let's say there are 10 4 grams and there are 17 8 grams. The total will be 10 plus 17, right? So I will have a 27. But we don't know whether is it 10 and 17 or not. It could be 13 and 14. It could be maybe 1 and 26. Just saying, right? The question here is where exactly should it be, right? That's the first set of information, and we'll call that equation 1. Then the second information is that we know the weight of them at 256, right? There are 27 of these items, and the total weight add up to 156. So how do I know is that since we don't know how many 4-gram weight, but I know that the weight, okay, the weight of the 4 grams, weight of 4-gram, or rather you can say the total weight of 4-gram weights, it's going to be number of weights, okay, multiplied by 4-gram. Agree? So this is M itself multiplied by 4. Or I'll leave the units out, so it's 4 times M. Okay, and that's why we have 4M. In the same logic, I will also have 8 times N, and the total will be 156 grams. And that formulates my second equation. Okay, formulation of the equation is very important because if you can't do this, then you're kind of stuck. All right, take some time to think about that. Make sure it makes sense, right? 4 times M plus 8 times N should make sense to give you 156 grams. So the first equation is the relationship between the number of weights, right? The first equation is the relationship between the number of weights. So it's counting. We don't care whether it's a 4-gram or 8-gram. We only know that if there is one of these items, we count it as one, right? So all in all, there are 27 of them. So you just literally count them off, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way until 27. So you know there are a total of 27 weights. But for the second equation, it is not just counting the number, it is to count the total weight, right? Essentially, right, it is 4 plus 4 plus 4 plus 4 until the number of 4-gram weights are counted, and then you plus 8 plus 8 plus 8 plus 8. And this total sum would give you 156 grams. Okay, so when you're counting the 4-gram weights, you're counting as 4 gram plus 4 gram plus 4 gram, and then the 8 gram will be 8 gram, 8 gram, 8 gram. You're adding all these weight together, the final number will be 156. So this is the important part, right? Because beyond that, all you gotta do is just to solve the simultaneous equation using any of the methods that we have taught just now. So you can either do elimination, you can either do substitution, or you can just do graphical. Doesn't matter, right? That's not the main point anymore. Okay, so application problem here is about the formulation, right? If you can formulate, the rest would just be technical solving. Okay, so I'm going to proceed, and maybe the quick one will be to do substitution. So I'll let equation 1, and I'll do this, right? And this will be equation 1a. Okay, this is equation 1. So in this case here, I'm going to substitute. Okay, I'm going to substitute inside equation 2. And then this will be 4 times of 27 minus n plus 8n equals to 156. Right, so you simplify the entire thing. 4 times 27 would be 108 minus 4n plus 8n. This would be 156. Okay, simplify the entire thing. Eventually, you should get 4n to be 48. Right, and last but not least, n would be 12. Okay, of course, not forgetting to solve the remainder of your m. Okay, m would be 27 minus 12. Okay, so it is 15. Right, example 5. David has 2 printers in his company, right? Printer A and printer B. He could print 1,500 pages either by running both printers at the same time for 12 minutes or by running printer A for 15 minutes, followed by printer B for 10 minutes. Then you're supposed to determine the printing speed of each printer. Right, at this juncture, it might be good for you to put a pause to this video and give it a try on your own. Okay, once you have tried it, then you can resume it to look at the solution. Okay, so if you have resumed this after you have tried the question but can't really solve it, then maybe it could provide you a little bit of a hint. So printing is about speed, right? So in a way, let's just call printer A, right? Both printer A and printer B have a speed, right? So the printing speed is the crucial thing here, right? The printing speed, okay, it's in pages per minute, okay? Pages per minute. Every printer is different. You can print very fast, you can print very slow. So it's dependent on the printing speed, and then you can achieve the number of pages, right? And right, so I'm going to label A. Okay, I'll use A to be the variable in which it is the printing speed of printer A. Okay, printing speed of printer A. Right, so at the same time, you can also label B to be the printing speed of printer B. Okay, so you don't know what is the printing speed of printer A. You also don't know what is the printing speed of printer B, but right, you know that is a number, right? Basically, it is a number of pages per minute as highlighted here. Okay, so A is the number of pages per minute. So we're going to have two set of equation, and it's based on the information of the question. It says he could print 1,500 pages either by running both printers at the same time for 12 minutes. 12 minutes. So A is the number of pages per minute of printer A, right? This means to say if I run it for 12 minutes multiplied by A, okay, I will print a certain number of pages. And if I do the same thing for printer B, it will be 12 minutes multiplied by the printing speed. Okay, so maybe I could also create a triangle for you. Okay, the triangle here is the number of pages, right? The number of pages you can do is the printing speed. Okay, the printing speed multiplied by time. Make sense? So if you can print 10 pages per minute and you print for 5 minutes, that will be 10 times 5. Right? So the total number of pages you could print is 10 times 5, that gives you 50 pages. Right? So the number of pages is based on the printing speed versus time. Okay, so take printing speed multiplied by time, you get your number of pages. So that's the reason why we take 12, which is the time, multiplied by A, which is the printing speed of printer A, right? And do the same thing for B, right? 12 minutes multiplied by the printing speed of B. And that gives us the total number of pages of 1,005. So then the other thing, okay, let me highlight this. So he could print 1,005 either by running both printers at the same time for 12 minutes, and that gives us this equation 1, or by running printer A for 15 minutes, followed by printer B for 10 minutes. Okay. Now for this case here, it's the same as saying if you run printer A for 15 minutes and then you add 10 minutes worth of printer B, you also get the same number of pages. Okay, and that gives you this equation. So now I have equation 1 and equation 2. Right? If you're able to formulate up to this point here, then the rest would be back to the technical solving. All right? Now it seems that we are able to simplify the equation based on the numbers that we have there. So 1,005, I can also simplify it further. So let's see. KR divided by 4. So if I take equation 1 and I divide it by 4, I will end up with 3a plus 3b equals to 375. Okay, so let's call this equation 1a, and I can also do the same for equation b. Right, if I divide it by 5, okay, you'll see that this is 3a plus 2b is 300. And this is now equation 2a. So by kind of simplifying the thing, right, reducing the coefficients down to for both a, I can therefore do a subtraction, right? Do an elimination by taking equation 1a. So now I take 1a and I subtract 2a, right? When I do that, I will have a 3a plus 3b. Okay, subtract 3a plus 2b. 375 minus 300. Right, when you simplify the entire thing, you should end up with just b is equals to 75. Okay, last but not least, you want to solve for A, right? So I'm going to substitute this back inside the equation. So you can substitute B equals to 75 in the equation, let's use equation 2A, right? So 3A plus 2 times of B, which is 75, is 300. So 3A is going to give me 150, and therefore A must be 50. All right. So once you're done with this, please proceed to your tutorials. That will be all. Bye, guys.